Hello everyone, my name is Ali Shriles from Polytechnic Master in Data Science. Today I'm going to present my mini course on evaluating visual analytics system with expert. This course aims to explain how expert users are involved in assessing visual analytic tools, how we measure their usefulness, usability, and overall impact in real analytical context. Here is the structure of this presentation. I will start with an introduction and conceptual foundation, then we'll discuss type of evaluation and expert evaluation process. After that, we will explore different evaluation method and two real-world case study, Jigsaw and EAD dashboard. Finally, I will conclude with key evaluation criteria, takeaways, and references. Visu- Visual analytic tools are often created for experts solving complex real-world problems like analytic engineers or doctors. These users evaluate the usefulness of the system. Does it actually help them reason better? They also judge its usability and trustworthiness. Evaluating with experts ensure that the system can be adopted and have real-world impact, but it's challenging. Sample size are small, experts have limited availability, and they have different level of expertise. To evaluate visual analytics system properly, we rely on two key frameworks. First, Mersner's nested model. It's defined four level domain. We evaluate relevance, abstraction, mapping, correctness, visual encoding include usability, algorithm include performance. Second, and and second framework, seven scenario, which describes seven evaluation goals: insight, performance, enhance experience, communication, workflow, algorithm, and collaboration. This model help researchers who choose what to evaluate and how to do it systematically. There are several types of evaluation depending on the study's goal. Formative improve the design during prototyping. Summative validate result on the final version. Comparative compare multiple tools. Long-term study adoption and workflow integration. Insight-based measure depth of insight. Expert review gather feedback early. Pilot study observe real-world usage. Each step answer a different research question: improvement versus validation. Let's zoom in on the two most common types. Formative evaluation identify issues and improve iteratively using methods like heuristic evaluation or cognitive walkthrough. Summative evaluation, on the other hand, measures success quantitatively using performance metric or usability tests. For example, Fortune and Johansson used heuristic for formative study, while Kang used a comparative summative study in the Jigsaw project. Evaluation also differ by their duration and goal. Short-term focus on detecting usability issues, for example, social heuristic studies. Mid-term study reasoning and interaction using think loud or peer analytics, like Aria Hernandez. Long-term observe real-world adoption and the MELC approach from Schneiderman and Pleasant. Combining all three gives a full understanding from early usability to long-term trust. Before starting an evaluation, you should ask a few key questions. What's your main research question? Which level of the nested model applies? Who are your participants, expert, analysts, or users? What resource and time do you have? And do you want to improve your design or prove its effectiveness? This checklist helps researchers choose the right evaluation strategy. The expert evaluation process usually follows six main steps: understand the context and objectives, select evaluation type and method, design the protocol, conduct the evaluation, analyze data, report the result, and the recommendation. This process ensures structure and scientific rigor throughout the study. Here is a more detailed view of each step with a real example. Step 1. Define the domain. Users and data, for example, anomaly detection in finance. Step 2. Select the method formative, summative, or long-term as described by LAM. Step 3. Design the protocol participant task metric. Step 4. Conduct evaluation. Use think aloud or interaction logs. Step 5. Analyze quantitative and qualitative results. Step 6. Report findings and recommendations following the long-term approach by Schneiderman and Pleasant. These examples show how theory and practice come together in expert evaluation. When we talk about experts, it's important to distinguish between two categories. Domain experts are professionals in the actual application field. For example, intelligence analysts in the Jigsaw study, they evaluate the analytical usefulness and relevance of the system. Interface experts, on the other hand, are usability or visualization specialists. Their focus is on design, interaction, and clarity, like in Fortune and Johansson heuristic evaluation. Combining both perspectives gives a complete evaluation, a system that is both usefulness and usable. There are many ways to evaluate visual analytic systems. Each method focuses on a different aspect: usability, reasoning, collaboration, or long-term adoption. Let's quickly go through six of the most recognized method in research. The heuristic evaluation is a fast, low-cost method. Typically, 3 to 5 visualization experts inspect the system and identify usability issues based on design heuristic. For example, Forshell and Johansson applied this approach and found more than 80 usability issue across multiple visual analytic tools. It's efficient to detect surface-level design problems early in development. The cognitive walkthrough method simulates how an expert user would perform a task step by step. Evalu- Evaluator mentally follow the workflow, asking, would the user know what to do next? It helps identify confusing steps and logical breaks in the design. For example, North and Schneiderman used this method to test a Spotfire visual analysis system. In the Think Aloud protocol, experts verbalize their thoughts while interacting with the system. This reveals how they reason, form insight, and interpret data. In Saria, participants produced 43 distinct insights in just 10 sessions. This approach captures the cognitive process behind data interpretation, not just performance metrics. Method 5. The MELC method. Multidimensional in-depth long-term case study focuses on long-term evaluation in real world context. Schneiderman and Pleasant proposed this to observe how tools are adopted over weeks or months. It combines usage logs, interviews, and field observation to measure trust, integration, and workflow impact. This method is especially valuable for real deployment studies. Peer analytics is about collaboration between two people, a domain expert and visualization expert. They work together in real time while researchers record their conversation, reasoning, and interaction. This approach was proposed by Arias Hernandez. It gives deep insight into how human and visual reasoning complement each other. Finally, eye tracking record where experts look on the screen their gaze path and focus point. It's reveal which part of visualization attract attention and where confusion might occur. Kochal used this to study cognitive load and identify overlooked areas during analysis. It's a powerful way to combine physiological data with analytical behavior. Let's look at a real-world case: Jigsaw developed by Kang Gold and Stasco. The goal was to help intelligence analysts find connection across the document people, places, and organizations. 16 experts participated, half used Jigsaw, half used traditional manual reading. The objective was to measure whether Jigsaw improved reasoning and efficiency. The study design included had 16 experts divided into two groups. Tasks had to find a relationship among people, places, and events. A 90 minutes session using think aloud and login interaction. Data collected included time, accuracy, number of insights, and usability score. These steps allowed the researchers to compare performance and reasoning depth between the two conditions. The results were impressive quantitatively. Users with Jigsaw completed analysis 25% faster, produced 40% more correct hypotheses, and rated usability equal to 81 divided 100. Qualitatively, experts reported lower cognitive load, better recall of relationships, and more complex reasoning patterns. The system helped them connect information more effectively. That's the power of visual analytics. The Jigsaw case shows that visual analytics enhance not only speed but also reasoning quality. Visualization fosters the formation of insight, and when users are trained, adoption improves. Finally, using mixed method, quantitative and qualitative, leads to a richer understanding of how experts think with data. Now let's move to second case study, the EAD dashboard developed by Alhaj Pleasant and Schneiderman. This project uses visual analytics for public health decision making with the goal of supporting injury prevention policies. The system was a collaborative dashboard for exploring real public health records from Canada. Participants included experts from health policy, epidemiology, and data analysis. The main goal was to see how visual analytics can enhance collaborative reasoning between domain experts. The evaluation used the group analytics approach, which extends the peer analytics concept to groups. Each session involved two or three domain experts plus a visualization facilitator who guided the discussion. They held two collaborative sessions analyzing real and jury data. Researchers collected interaction logs, video recording, and post-session interviews to evaluate communication, coordination, and shared understanding. The results were very positive. First, collaboration improved. Experts built a common understanding of problem and aligned their perspective. Second, the reasoning was enhanced. Visualization helped them compare findings and make decisions together. Third, the system had a high perceived usefulness. Participants cited the dashboard clarified discussion and guided their decision. This shows how visual analytics can transform individual insight into collective intelligence. When analyzing results with valua- valuation criteria. When analyzing results, we rely on several evaluation criteria: performance, time and accuracy, insight, number and originality, usability measured with the usability score, cognitive load with NASA TLX, trust through confidence rating, attention using eye tracking metrics. The metric helps capture both efficiency and cognitive impact. Data collection and analysis. Evaluation combines quantitative, qualitative, and behavioral data. Quantitative include time and score. Qualitative include interviews and coded insight. Behavioral include logs and or guess tracking. Researchers then triangulate these sources to obtain a complete and balanced understanding of how experts interact with the system. Every evaluation faces some limitation. Internally, we may have bias or learning effects. Externally, there is limited representativeness of participants. We must also check metric adequacy to ensure that what we measure really reflects insight or trust. And finally, avoid overgeneralizing from small expert sample. When reporting results, we should clearly include context and objective system description, participant and task methodology, quantitative and qualitative result, discussion and conclusion, and here are the key takeaway from this presentation. Use theoretical framework like Manzner. Combine multiple expert methods for depth, balance, performance, and insight metrics. Address validity transparently to ensure credible results. Here, here are the main references that shaped this course. Thank you very much for your attention. I hope this session helped you understand how expert evaluation strengthens both research and real-world decision making in visual analytics.